All right. Hey, everyone. Uh, so today we're going to run through uh, classifying simple chemical reactions. Excuse me. So uh, you guys have done balancing and sort of writing from words to the formulas, the formula equations, right? We've done that so far. Now, this is going to be actually like looking at the reaction, the equation, and determining what type of reaction is occurring, based on the format of the reactants and products. All right. So, um, just a quick reminder for our chemical equations. Okay. We have reactants are the substances that enter into a reaction, stuff you had before. And those are on the left side of the chemical equation. And then on the right side, we have are products or whatever's left, whatever's created after the chemical reaction is completed. Okay, so we have reactants on the left side, products on the right side. Now, there are the first type of chemical reaction is called synthesis or direct combination reaction. Okay. Synthesis means to like put something together or create something. Okay. This is where two or more reactants from the left side come together to form a single product. All right. So the format is you have reactants on the left side. There are going to be two or more substances. It could be elements, it could be compounds, whatever. You're going to have two or more substances. On your product side, and this is why it's bolded here, is because if you have only one compound on the product side, it has to be a synthesis. All right. So I've given you a couple of different formats here. What I've done on all of these, if you look, is I've done this like variables as like a generic format. Like this would be element because it's one single thing, element, element, and they come together to form a compound. Okay, so and then here's a specific example. Iron plus oxygen coming together to form iron oxide. Okay, here's another example, slightly different. This is where you have an element and a compound, and then they come together to form one compound. So like oxygen combining with potassium chloride, creating potassium chlorate. Okay, those are both synthesis reactions. Um, one of the first reactions we ever really looked at is a synthesis. One of the first reactions that I ever really talk about, water, the creation of water, hydrogen plus oxygen creating water. That's a synthesis reaction. Okay. All right. Next one is a decomposition reaction. Decomposition is essentially the opposite of synthesis. It's where you have one single reactant that gets broken down into two or more products. So you're only going to have one thing on the left side. Okay, opposite of synthesis. Reactants, on the reactant side, you will have one compound. On the product side, you will have two or more substances, elements or compounds. Okay, so a couple of examples here. And you can see same, like I've got here, this one we've got a compound splitting into two elements. So NH3, ammonia, splitting into nitrogen gas and hydrogen gas. That's a decomposition reaction. Okay. This one you might be somewhat familiar with. I don't know about the reaction, but the substance you would be. H2O2 is hydrogen peroxide. That's the stuff that we put on cuts to kind of disinfect them. That bubbles a little, stings sometimes. Okay. Hydrogen peroxide, when you buy it, it comes in these brown bottles, right? The reason for that is because light causes a decomposition reaction for hydrogen peroxide. Hydrogen peroxide naturally decomposes or breaks up into water and oxygen gas. And light actually catalyzes it or makes it happen faster. So hydrogen peroxide breaks into a compound and an element, water and oxygen. Okay. All right. Third type. These are what are called single replacement reactions. It's where an uncombined element takes the place of an element that is part of a compound. Okay, so what's the format going to look like? Well, your reactants are going to be one compound and one element. Your products are going to be one compound and one element. Okay? So on the left side, you're going to have a compound and an element, and on the right side, you're going to have a compound and an element. Now, the formats. There's actually two different ones for single replacements. And it's based on what type of, it's based on what thing is switching, the single element switching into the compound. There's a cationic single replacement, and there's an anionic single replacement. So remember, cation is, so a cationic single replacement is where the positive ions or the cations switch places. Okay, so let's look at this format. So I've got element and compound, and the A and the B are cations. They're positive ions. The X is the anion. So like here, magnesium is a positive ion, right? If you look on our periodic table, Mg is a +2. Sodium and oxygen, sodium oxide. Sodium is the +1. Oxygen is the -2, right? So the magnesium and the sodium switch spots. The sodium now comes out and is alone by itself, and the magnesium now combines with the oxygen. In an anionic single replacement, it's similar. Okay, it's just the negative ions or the anions switch places. So here, it's like okay, those are the anions. And then up here, these were the cations. Okay, so for the anionic, we still have an element and a compound and an element and a compound on the product side, but it's the anion, so Cl, chlorine, if you look on the periodic table, is a negative, okay? Sodium is a positive, we already looked at that, right? And sulfur is a negative, -2. So the negatives switch spots. The sulfur comes out and is alone, and the chlorine now combines with the sodium. Okay. The analogy I use for this is sort of like dancing. Like you have in general, like so say you have a guy and a girl dancing. That would be like the compound, because you have to have the compound has to have a positive and a negative, right? So you have a guy and a girl dancing. If a guy comes up and wants to cut in, okay, he's going to cut in for the other guy, and he's going to dance with the girl. So the other guy switches places with the guy that is dancing with the girl in the quote unquote compound. So if it's positive, the positive is going to take the place of the other positive, not combine with it. Okay. Same thing with the anionic. So if you've got a couple dancing guy and a girl, and a girl comes up, she's going to take the place of the girl that was in the couple. The new girl is going to dance with the guy, and the girl that was with the guy originally is going to now be alone. Okay, so here, the negative switch spots. Now, if you look at something, how do you know if it's cationic or anionic? Well, the simplest way to know is on the reactant side, the left side, look at the single element. If the single element is positive, it's going to be a cation because that's the thing that's going to be switching. If the single element is a negative ion, it's going to be anionic because that's what will be switching. Okay, that's for single replacement problems. Okay. The next type 4, are double replacement reactions. Okay. In a double replacement, it's similar, but not the same to a single replacement. In a double replacement, atoms or ions from two different compounds replace each other. So what is the equation going to look like? Well, on the reactant side, there will be two compounds. On the product side, there will be two compounds. Okay. So we have AY plus BX, two compounds, AX plus BY. Okay, now if you notice, I'm going to use the same colors I used on the other side. I'm going to use yellow for my cations and green for my anions. So okay. Yellow cations, green anions. So when you're looking at this, what you have to remember is that, and if you're just looking at if they give you the whole reaction, it's not a big deal. But like if you're trying to figure out, like it always has to be a positive and a negative together. Okay, so if you look and see what happened here, the positive from the first compound, the cation from the first compound goes with the anion from the second one, like this. And the cation from the second compound goes with the anion from the first one, like that. Okay. Again, I use the same dance analogy for this. The idea that if you have two couples dancing, okay, a guy and a girl and a guy and a girl, if they just decide that they want to switch up for the next dance, the guy from the first couple is going to go with the girl from the second couple, and the guy from the second couple is going to go with the girl from the first couple. They switch up. Okay, that's a double replacement reaction. All right. Fifth category, unique reactions. So there are many other complicated. These are very simplified reactions, styles of reactions. Okay, that's all we're going to concentrate on in Chem 1. There are many other much more complicated reactions that don't fit neatly into one of these 5 basic categories. All right. You're not going to have to worry about that other than this one that we're going to memorize and use. But other than that, like I just put this in here to kind of let you know, like, yeah, this isn't the only choices. There's a ton of other things. These are just the most simplistic, generic ones. Okay. The one that we are going to learn is a combustion reaction. Okay. In a combustion reaction, it's a reaction in which a hydrocarbon is a compound containing hydrogen and carbon. sometimes oxygen, but it has to have hydrogen and carbon, burns in the presence of oxygen gas. So burning paper, burning a piece of wood, whatever, those are combustion reactions. Okay. The products of this reaction include carbon dioxide, CO2, and water, H2O. So I've got an example here. This is the hydrocarbon. All right. This is the hydrocarbon. Is combining or reacting with oxygen gas, O2, to produce two products, carbon dioxide and water. Okay. In a combustion reaction, the highlighted ones, the oxygen on the reactant side, carbon dioxide and water, are always the same. It always has to have those parts. Okay. Now, the hydrocarbon can change, but the hydrocarbon always has to have hydrogen and carbon in it. Sometimes it has oxygen, sometimes it doesn't, but it always has to have hydrogen and carbon. Okay. So it's a combustion reaction. If you have something with hydrogen and carbon and it's combining with oxygen, and on the product side, you get carbon dioxide and water. Okay. Has to be like that. So if you have something else, like you could have a hydrocarbon, but if you don't have it being added to oxygen and producing carbon dioxide and water, if any of those parts are different, it's not a combustion reaction. Okay. Or you could have something combining with oxygen. All right. But it's not going to produce carbon dioxide and water, only those. And it won't have, if it doesn't have those parts, it's not a combustion reaction. Okay. All right. So that's it for the notes. I'm going to do a separate little video with the homework to kind of do a couple of examples and just sort of give you a little head start on the homework. All right.